सो स्टूडेंट्स बढ़ते हैं नेक्स्ट क्वेश्चन की तरफ। अब इस क्वेश्चन में दिया हुआ है हमें एक फिगर जिसके अंदर पी क्यू पैरेलल है एस टी के। सो आप देख सकते हैं यहाँ पे एक लाइन है पी क्यू और यहाँ पे एक लाइन है एस टी। बोथ आर पैरेलल टू ईच अदर, इट इज गिवन टू अस। ऑल्सो there is an angle named PQR is equal to 110, as you can see here in the diagram. So PQR, it's 110. Also there is one more angle given to us, that is RST, that is 130. RST, it's given us as 130 degrees, right? And we have to find out angle QRS. So you can see QRS, that means this angle is what we have to find out in this question, right? Now how we will able to find out this angle? So there will be a construction in this diagram, so observe it carefully. I will just simply extend this line PQ which touches this SR line at point M. Getting my point? So I have given this point a name M. So what I have done, let me just write it in construction, but before construction let me write what is given to me in this question, right? So here it is given to me that PQ is parallel to ST. Further, angle PQR is equal to 110 and RST is equal to 130 degrees, right? Now, construction here is extend this line PQ. You can see here, extend PQ to SR. So I am extended PQ to SR, touching it at M point, right? So the construction is clear to you now. Now moving further, find out. So to find here is the angle QRS. That is what we have to find out in this question, right? Let me just make the question sign clear. Now the thing is, if you just observe that PQ was already given parallel to ST. So I have extended PQ to M. That means now PM is parallel to ST. It's clear? Because PQ and PM makes no change. They are same line, right? So I'm just starting the proof here. So now PM is parallel to ST. So if PM and ST are parallel, then you will find out that SM, this line, or you can say SR, right? So better if you say SM. So SM, you can see here, is kind of a transversal line for both the parallel lines. Getting my point? So you can see SM is transversal, right? So if you just observe, there will be a shape of Z here, like this. If you just observe it right here, like this. So this and this angle are alternate angles, right? So this is 130, then definitely this will be going to be 130 degrees because they are alternate angles and alternate angles are equal. So this implies, you can see here, that angle TSM, so you can see here, angle TSM is equal to angle SMQ. That means this one. So angle SMQ, right, equal to 130 degrees, right? So now we got this angle. Now further we have to find this angle. So if you just observe that this angle in combination with this is forming a 180 degree angle. So that means this and this angle are a linear pair. Getting my point? So that means their sum is going to be 180 degrees, right? So first let me just make some space here. So I'm rubbing the question here because we know what we have to find out. I have written here, so there is no need of question right now. So I'm just simply rubbing all over the space, right? Now moving further, now you can see what was this point? This was S, right? Now you can see angle SMQ plus angle QMR. If you just observe it carefully, SMQ, that means this angle, and QMR, that means this angle. So both are forming a linear pair, so that they will be equal to 180. So linear pair, I'm writing down here. So both the angles are linear pair, so their sum is equal to 180 degrees, right? Now we know SMQ is equal to 130 degrees, right? We have just observed here that this SMQ is equal to 130. So I'm writing it down here. So plus angle QMR is equal to 180 degrees, right? Now transfer this 130 degree over to right hand side. This will bring me angle QMR as 180 minus 360. You can see the 130 was in the positive at the left hand side, so it will become negative after moving to the right hand side, right? Now further, if I just subtract this, so this will give me 50 degrees, right? So angle QMR is now 50 degrees. So let me just place this 50 degrees here, right? Also, if you just see, this is also forming a linear pair. This 110 angle, if you see, is forming a linear pair with the inner angle. But also there is one more property. If you don't want to find out this, you can also solve or you can say find out angle QRM by simply a property of a triangle. Let me first explain you a property of a triangle so that it will be easy for you to solve. I was applying the method here of a triangle here. So all the sum of all angles of a triangle is 180. We know this. We will find out by subtracting 110, we will get this, and then we can find out this. But there's also one property of a triangle. If I just take this triangle similar here, so I've told you if we extend one side of a triangle, so there is an external angle formed there, right? Whose value is equal to the sum of interior opposite angles. Getting a point means this and this. So exterior angle is equal to the sum of interior opposite angles. So if you just observe this diagram, this is the exterior angle 110 and interior opposite angles are 50 and the angle which we have to find out. So 110 is going to be equal to 50 plus angle this which we have to find out. Getting my point? So what I'm going to do is simply rub here. So let me first write the R point is here. Now let me just rub this. So applying exterior angle property. So we can write this as angle, you can say QMR plus angle QRM, right? So QRM, or you can say QRS, they are going to be the same. So don't get confused if we are finding QRS or QRM, because QRM or you can say QRS both have angle R in the middle. That means angle is forming on R. So we can say it like QRM or you can say QRS. So there is no change, right? So you can say, you can also write it as QRS. So need not to just worry out here. Now you can see exterior angle, that is 110, is equal to the sum of interior opposite angles. You can check out. So this M and R are the interior opposite angles, right? So this is angle M, this is angle R, right? Now what I'm going to do is simply put the values of them. So let me just rub and make some space here. So what is angle QMR? So angle QMR is 50 degrees. So let me just place it. And angle QRS is what we have to find out here. You can see here. So angle QRS equal to 110. So transfer this 50 over to the right hand side. This will bring angle QRS as 110 minus 50. That means 60 degrees, right? So this is what we were finding out, that angle QRS or you can say QRM is, you can say 60 degrees, right? So that's all. So students, let's move further without wasting any much of your time, right? Now the question number 5 says, in the given figure, AB is parallel to CD. Now you can observe the two lines here which are given parallel to us, that AB and CD are parallel to each other, right? Further, angle APQ is given to us as 50 degrees. So you can see here I have mentioned here that angle APQ is 50 degrees, right? Further, angle PRD is given to us as 127. So let me just show you PRD, this 127, right? It is given to us. Now we have to find out angle X and Y. So you can see here in this triangle, we don't know angle X and Y. So first thing after observing this figure that strike into your mind is, you can see here these lines are given parallel to each other, and this is a transversal which is intersecting these two parallel lines at P and Q. So there's a Z structure forming here. You can see Z here. So these are two alternate angles, right? They are going to be equal to each other because the lines are given parallel to us. So I'm straightly writing that the solution here, that AB is given to us as parallel to CD, right? Now also this PQ is transversal. You can see here this PQ is transversal. So this implies angle APQ. You can see APQ is going to be equal to PQR, alternate angles, right? So angle PQR, both are going to be equal to, let me just write that. This APQ is, you can see 50 degrees, and PQR, that means X, right? So we got the value of X as 50 degrees, right? Now let's jump over to Y here now. Now you can see how to find Y if you just observe this triangle here. So I'm going to apply exterior angle property, which I have just shown you in the previous question. Let me just show you again here. So in any triangle, like here in PQR, if we simply extend any line out of any three sides, so there's an exterior angle formed, right? So in this case, this exterior angle is given to us as 127 degree. Now we know exterior angle property, which says the value of exterior angle is equal to the sum of interior opposite angles. So these are the two interior opposite angles to which this angle, exterior angle, is going to be equal to. So their sum is going to be equal to the exterior angle. So in this case, you can see both the interior angles are X and Y. So this 127 is going to be equal to the sum of X and Y, right? So simply in triangle, you can say PQR. You can see here I'm taking triangle PQR. So in triangle PQR, we know that the sum of X and Y, the interior angles, opposite angles, is going to be equal to the exterior angle. So I'm directly writing X plus Y is equal to 120 and 7. So this is exterior angle property. I'm not writing full, I'm just writing the short form. Exterior angle property, right? Now, you know X is 50 degrees. So I'm just substituting the value of X here. The plus Y is equal to 127. Now transfer this 50 over to the right hand side. So this will give me the value of Y as 127 degree minus 50 degrees. Now what is 127 minus 50? Let me just show you right here. So there is 7, 12 minus 5 is 7. So that is 77 degrees, right? So this is going to be the value of angle Y. So we have calculated both X and Y. That was all about in this question, right? That's all. So students, now moving over to the last question of this exercise. So after this, we will going to be discuss exercise 6.3, right? So this last question is important question of this exercise. So do observe it very carefully, right? Now in this particular question, it is given to us that in the given figure, PQ and RS are two plane mirrors. So if you observe this figure, you will see that there are two plane mirrors placed parallel to each other, named PQ and RS, right? Now further, there is an incident light ray AB which is striking this mirror PQ at point B and then get reflected to a path BC, then CD. So you can see after reflecting from point B, the light ray actually strikes the second mirror RS at point C and then get reflected back to the path CD, right? So here you can see in the diagram angle 1, 2, 3 and 4 are placed. Now you will see this angle 4 is actually the incident angle and this 3 is reflected angle and this BN is normal, right? So normal actually shows us that angle of incidence is equal to angle of reflection. Also this normal is perpendicular to the mirror PQ. Also when after the reflection this ray BC strikes the second mirror at point C, there is also again a normal drawn named CM. which shows us that the angle of incidence is equal to angle of reflection, right? Now, after reflection, the light ray took the path CD, right? So now, in this question, which is given to us is that both the plane mirrors are parallel to each other, but what we have to prove in this question is that this light ray AB is parallel to this reflected light ray CD. So this incident light ray AB is parallel to CD. This is what we have to prove in this question, right? So what is given to us in this question is, I'm just writing down here, so solution to it. So you can see here, this PQ mirror is parallel to RS, right? Now the first thing is, let me just move to a scientific thing here. So whenever a light ray strikes a plane surface, so you can see this is a plane surface, so it gets reflected back on the similar angle which it strikes with normal. So normal is a line which is perpendicular to a plane mirror, right? So this is a normal. Let me just represent it above. So this is normal. Normal is kind of a perpendicular line to the plane mirror. Now, whenever this incident light ray strikes to a plane mirror, so it will make a certain angle with this normal line, right? So, for example, if I just say it strikes at an angle of 30 degrees, then definitely it is going to be reflected at 30 degrees with normal. So the reflected light ray also will have 30-degree angle with this normal line. Getting my point? So this is the scenario which is being applied on in this question, right? So you can see here, this was the incident angle, this was the reflected angle. Both are equal to each other. So if you see here, that this will show you that angle 1 is going to be equal to angle 2, angle 3 is going to be equal to angle 4, because we know that angle of incidence is going to be equal to angle of reflection, right? So we are going to move step by step. Now we know the formula that will be applied here. So let's move further. Now the first step what I'm going to apply here is, by law of reflection, we know that angle of incidence is equal to angle of reflection. This implies angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Let me just give it a first equation right here. Now, next step is, if you observe that both the perpendiculars are applying on the parallel lines, right? Now both BN and CM are perpendiculars to parallel lines, right? That means both the perpendiculars are going to be parallel to each other. Let me just explain you here with drawing a diagram. So suppose these are two parallel lines, right? Name AB and CD, right? Now both lines are parallel to each other. That means the distance between both the parallel lines are going to be same. So you can see the distance is same here. So I have drawn various perpendicular lines. So you can draw numerous number of perpendicular lines between two parallel lines, right? So there are numerous perpendicular lines between two parallel lines. All lines are going to be parallel to each other. You can see here, all are parallel to each other. So similar kind of thing is here. When we have drawn a normal to both the parallel lines, both the normals are going to be parallel to each other. You can see both the perpendiculars are parallel to each other. That means BN is parallel to CM. So let me first make some space above so you can understand what I'm talking about. So I'm rubbing the question here. We have to prove AB is parallel to CD, right? So we don't need to just take a look at the question now. So let's move further. Now you can see here that I've told you that this BN is parallel to CM. So let me just write that BN is parallel to CM, right? Since BN is parallel to CM, now you will observe if this is parallel to this, then this BC is going to be the transversal, which is intersecting both the parallel lines at point B and C, right? Then BC is transversal. Let me just write N clear. Transversal, right? So this angle 3 and 2 are going to be equal because they are forming a Z shape, you can see here. So angle 3 and 2 are alternate interior angles, right? So this implies angle 2 is equal to angle 3, alternate angle. So you can see here, this is clear, right? Now I'm just giving it equation number 2. So let me just tell you, if angle 2 is equal to angle 3 here, and 1 and 2 and 3 and 4 are equal to each other, right? So let me angle 1 plus angle 2. So let me find out angle 1 plus 2 here. So what is angle 1 plus 2? Now if you can see here, angle 1 is equal to 2. So I can write at the place of angle 1, angle 2, right? So I have just placed angle 2 at the place of angle 1. So angle 2 plus angle 2 is going to be equal to 2 angle 2, right? Similarly, if I just have to find out angle 3 plus 4, then you will observe that angle 3 and 4 are equal to each other. So this will give us that if I just place angle 3 at the place of angle 4, that will make no change because angle 3 is equal to angle 4. So I have placed angle 3 at the place of angle 4. That will make no change. So angle 3 plus angle 3 will give you 2 angle 3, right? Now, if you can see here, from the previous equation number 2, angle 2 is equal to angle 3. So if angle 2 is equal to angle 3, then definitely 2 angle 2 is going to be equal to 2 angle 3. So twice of angle 2 is going to be equal to twice of angle 3 because angle 2 is equal to angle 3, right? That means both the equations have the right hand side same. Then definitely their left hand side will be going to be equal. Let me just give them equation 3 and equation 4. Then let me just rub some space here. Then you can see here from equation 3rd and 4th, we can have angle 2 plus angle 1 plus angle 2, sorry. So angle 1 plus angle 2 is going to be equal to angle 3 plus angle 4. You can see here. So this is going to be equal to this and this is going to be equal to this. Now the right hand sides of both the equations are equal. That means the left hand sides are going to be equal. That means angle 1 plus 2 is going to be equal to angle 3 plus 4, right? Now you can see here angle 1 plus 2 is angle BCD. So let me just write here angle BCD, and angle 3 plus 4 give you ABC. So angle ABC, right? Now angle ABC is equal to angle BCD. That means these two angles are alternate angles. If you just observe that, this is forming a Z here. You can see here. Let me just draw it right here. So they are forming a Z structure. So that means they are equal. So alternate angles are equal. Then the lines are going to be parallel right here. That means AB is parallel to CD. Let me just write that they are alternate angles. That means AB is going to be parallel to CD. This was what we have to prove in this question, right? So just rewrite it and just concentrate on this question so that you can understand it better. That's all from my side.